Hello, okay. Today we're going to talk about factoring. Factoring trinomials. Our title's here in the page here. You can see on the screen. These two words, let me describe what they mean. Factoring means dividing out, dividing things into two parts or more parts. Tri is three terms, trinomial, and we have that right here. If you're watching this vlog, I'm hoping that you already know how to multiply monomials, binomials, as well as trinomials, and multiply them. Right now, we're going to work back to their pre-multiplied state. So we have two binomials that will separate this trinomial into. Factoring, some people may sign it with the parentheses symbols or the division sign. I will fingerspell it or divide or say the parentheses symbols because factoring can mean different things. Now, as we learn about this topic, factoring trinomials, we have a first and second and third term. Our first term, the coefficient, is 1, is 1x squared. Okay? Second and third terms have different coefficients, different numbers depending on our example. Now, if we're looking back to how we used to multiply binomials and monomials and whatnot, let me go back and show you an example before we proceed. So, as we look back and multiply our binomials, first thing we'll do is distribute. We've used the word before, FOIL, F-O-I-L. Basically, the principle we're using is distributing one binomial over the other binomial. So we're going to multiply x across the second binomial and then 4 across the second binomial. So in our red and our blue, we can see what we have. We have 4 terms. Now we have to look at the like terms. If we have any, we can see in the middle here 3x and 4x. And when we add them together, combine them, they become 7x. So now As we look at our third term, the 12 here, that came to be because we multiplied 4 times 3. Now the 7x came to be because we had 3x and 4x, and they added together to become 7x. Now our first term is made up of just x times x, and that's going to be constant right now, consistent for now. Now as we go back, we can look at our first term, and I've already set it up where it's x squared, and we have our two binomials, x and x. As we look at the 6, our third term, so how does 6 come to be? We need factors of 6, things that multiply together, two numbers that multiply to become 6. Now, how does 6 come to be? What two pairs or several pairs? Well, 1 times 6 will work, and then 2 times 3 will work as well. Okay, so we've generally we've discovered what pairs, what factors 6 have. Okay, but we have a positive 6. Now, in multiplication terms, how can you have a positive answer? Now, if both numbers that you multiply are positive, your answer is positive. But now, also, if you have two negatives that are multiplied together, that becomes a positive answer. So we could have -1 times -6, or -2 times -3, as well as a positive possibilities. So now we have four distinct possible pairs, and where they all multiply to become positive 6. Now, we have a second condition in this trinomial to look at. The middle term, the second term, plus 5x okay. All right. For now, we're going to look at the positive, well, 5x, and the coefficient being 5. The important thing is, the x is always there for now in our current trinomial, but the coefficient we're concerned with right now. Now, we're looking at the pairs that multiply to become 6, and I need to know which pair will add up or combine to be positive 5. Oh, excuse me. I gotta change that. I don't mean multiply. Okay, so as I look at 1 plus 6 is 7, 2 plus 3, that would be positive 5. There could be other pairs that satisfy this. So we have negative 1 plus negative 6, negative 7. And then negative 2 plus a negative 3, that's negative 5. So now we have positive 2 and positive 3. They satisfy both conditions. 2 times 3, positive and positive, is positive 6. And then 2 plus 3 is also 5. Now both conditions are satisfied in our trinomial. So let's put this in our two binomials here. This is important. If I were to put x plus 3 and then x plus 2 second, switching the order here, it would not matter because multiplication order does not affect the answer. It's commutative, meaning the factors can be moved around and put in different order. Now, I believe I'm right, x plus 2 times x plus 3, but I need to test it. Now, what we can do is just multiply and see if we go back to our original trinomial. Okay, here we have it. Now, as I multiplied through, oh, wait a minute, I forgot my squared. I'm sorry. So there you have it. This is our answer, the quantity x plus 2 times the quantity x plus 3. And this is explaining how the process works. It's pretty exaggerated right now, but the next vlog, we're going to have separate examples. Thank you, and I'll see you next vlog.